Hello. Hi. I see 2 concurrent viewers. Hi. Good evening. You can use the chat. So this is very casual today. What I have here with me is my big database of Polkadot and Kusama data. And I'm just going to dig around in the database. So I have Kusama, I have Polkadot, and I have all the blocks, all the recent blocks, roughly until 13 million in Polkadot, and I think 60 million in Kusama. I haven't checked the last ones. And what I want to do today is just dig around a little bit. You can leave me a comment if you would like to see something, and else I'm just going to dig around a little bit. And first thing I actually want to look at is what were the biggest transfers that were happening on Polkadot recently. The way that I approach this is the database has similar data to what you can see on Subscan. So for example, on Subscan you can see all the extrinsics, all the calls, all the events that were happening. And so what I'm interested in is actually seeing how a transfer is working. So I'm just, digging around the Subscan, I'm picking a random transfer and analyzing a little bit how a transfer is working. So what I see here in Subscan is that whenever there is a transfer, the call is basically balances transfer. So what I'm going to do is I'm going to look into my database. And here I have a table with all the calls. So basically similar to every extrinsic that has ever happened. So what I can see here is there is a section and a method that's similar to the palette and the method being called. And so I'm going to look at all the balances transfer methods that I can find. So I'm going to take all the calls that I have on balances transfers, and then I'm going to check the block number, and I'm going to just check a few blocks so that I'm not wasting a lot of money initially on this query. And let's pick something from the area of the block of the 10 million blocks. So this is between block 10 million and 10 million 10,000, something like this, maybe. So okay, if I would do this, it would just give me 10,000 blocks, 10,000 basically all the calls in this area. And so now I'm adding another criterion, and what I want to do is section equals balances and method equals transfer. So let's see what I'm getting here. Okay, I'm getting all the transfers that were happening in this range. Okay, and now you can see my result table here, and the result table basically gives me, by the way, you can say hi in chat so that I know who you are. So this is basically a table of all the extrinsics of all the transfers that were happening, all the calls that were happening. So you could filter them and basically say I only am interested in all the extrinsics that were successful, and maybe filter out those that were not successful, but we're going to do this a little bit later. For now, we're basically interested in the raw data. And then when it comes to tuning it down a little, go into more details, we want to have more precise data. Initially, we don't need to have 100% precise data. Okay, so we're going to look into the arguments here. And this is a little bit of a JSON. So I think I recently, So I'm going to look at the JSON value here. Should have prepared it a little bit. I think it's JSON value, and then I'm going to look into the args argument, and then I'm looking into dollar. Let's look at the value and see if this is working. Value. Let's see if we can do something like this, args, and we might want to see who is sending this. So this is the address. So who is performing the call, what data did they send, and can we already extract the value? Let's see if we're getting something. No, it's an invalid path. Okay, one more try. So this is actually, oh, it's the value. Let's see how I'm doing this in a similar call. So, picking one of my routines, extract proxy calls should give me some insights in how I've been doing this. Yes. Oh, yeah, I can just, can I just access this? This is possible. args.real, args. And then cast to a string. Okay, let's try this. So maybe it is just args.value. Yes, easier than I thought. Okay, and then I have a destination. So this is args.dest destination. And that's basically it. Okay. Yeah, okay, and the destination can be broken up a little bit, but usually it's an ID, so this would be args.destination.id, big I, yes. Good. Okay, so what I have now is I have a list of addresses. This is basically who is sending, which amount of value to which address, right? So now I need to cast this a little bit and basically make it meaningful data. I think what I'm doing here is string. Is it giving me the right information? Yes. And this, can I do int 64 maybe? Let's see if this works. Guessing a little bit, but yes, this works. No, it's not an integer. Because it's a big decimal. So this would work likely. Yes, and then I can cast this as big decimal. Yep, and I got a very big number now, and now I can aggregate all of this. Okay, so this is basically the first step. Let me save this away here. Ching, 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 ching. Okay, so this is raw transfers. Okay, and now we're going to look at all those raw transfers, and I can put away the args here. And I can just aggregate this in a way that is interesting to me. So I could either take the outgoing address or I take the incoming address. But maybe let's group it together by outgoing address and incoming address. So this is basically the address as the sender, and this is the receiver. And then we have the value that is being sent. Right? So take this as a value, and we now got a very nice table of the sender, of the receiver, and the value. We still need to filter this later on, but now we can actually group this. So we would be taking the sum of this, and then we would be grouping this. So we would be saying group by sender and receiver. receiver. Yes, and now we have a very nice group by, and now we could actually take the all-time values and basically see what is the all-time sum of all the transfers that we're doing. So going to copy min block max block here so that I can extend this easily. And what I want to do is, if it's all time and it's Polkadot, I think I have 13 million blocks for Polkadot, so this is 14 million, so this is 14 million blocks. Let's round it a little bit. Okay. Okay, so we're setting this to min block and max block. Okay, 3 GB per run, but 3 GB is okay actually. It's not too bad. So yeah, let's run. Okay, this will take a tiny bit, but it shouldn't take too long. So what it's doing now is going through all 14 million blocks that I have, go through every call that was ever sent, and aggregate it together. Okay, we processed 1.9 GB. And we have a few receivers where it didn't work. I guess they have an index or something similar. So we could have a list of to-dos. And so one thing is only successful extrinsics would be relevant. And then we could also consider unpack receivers that resolved to null. And I would say this is likely indexes. So not the pure address, but an index. So we can do this to clean it up a little bit. So this is a basic table that we can now use. Maybe we could be materialized view or not. Let's store it. I mean, if I want to change the query later, maybe I would not want to. Maybe I would like to have it cleaned up immediately. I guess I can fix it later. Yeah, let's progress and see how deep we can go. Yeah, but resolving it would take maybe too much time, so let's not resolve the receiver question. Let's go for the big chunks here. So we have a table of senders, receivers, and values. Let's save this result and work with this. So this is a big query table, and it's living in Polkadot, right? Polkadot, and we're calling this transfers. Yes. Okay. Yeah, if you have any questions, comments, feel free to post them in chat. So we have a table of all the senders, of all the receivers, and the value that has been transferred over time. And now we can look at some interesting first facts. For example, who is the biggest receiver? Who is the biggest sender? So let's do that actually. So I want to get everything. And I want to know, no, basically I want it to order by value, descending. Yes, because then we have, yeah, then we can just, for example, yes, if we order it by value descending, what we would be getting is who were the accounts that transferred the most value of all time, right? Which is already an interesting question. But this is actually executing for some time. Yes, okay, and now we got the accounts that were transferring the biggest value of all time. Maybe we can cast this in a way that it is better readable, because this is a very big number and we don't know how much dot this is actually. So how about we just remove the last, basically everything after the decimal point. So we would be saying select sender, receiver, and then we take the value and we divide it by the power of 10 to 10. And this would give us the number of dots that were transferred. Yeah, I think this will make it much better understandable. Okay, and we're getting a result, and this doesn't look reasonable to me. Oh, this looks reasonable. This looks like, divided. 2 to the power of 2 times 10 to the power of 28 dot. Is that reasonable? You know, I'm not sure if this is reasonable, but maybe we can look it up and just check out which account it is. It is very likely a centralized exchange. It is an account that closed down some time ago. Okay, let's look at if I made any mistake here. Divided by the power of 10 to 10. What about? Okay, let's just, I mean, it wasn't a lot of transfers, but that also wasn't a lot of dot that was being transferred. So maybe my query is wrong somewhere. Let's look it up. It was summed. That doesn't look too reasonable. Okay, let's see if there were some insane transfers, but I think this will not. I mean, it's a few thousand. Oh, okay. Yeah, of course. Okay, yeah, so here you see the reason why you're filtering out, because of course some people put in the wrong numbers or tried to find a mistake in a system, so they actually tried to transfer huge amounts of dot. I would guess they got maybe the decimals off. Okay, so we actually do need to filter by the right number of extrinsics. So, but only the correct extrinsics. So, okay, that makes the query a little bit more complex, but we can still pull this off. Okay, so we want to have only calls that are part of an extrinsic that's successfully executed. So let's just look at blocks, and I think we have a field there that says if they are, no, not blocks, but extrinsics. If they have been successful. No, we do not yet. Okay, super interesting. So we have to filter this out. We have to find out if an extrinsic was successful or not. So how do we do it? It's actually a very interesting case of on-chain analytics. How would you find out, just by looking at raw data, if an extrinsic was successful or if it failed? And I assume what you have is, it depends on where it is in the raw data. But so we have an extrinsic here, and there is a single event. Extrinsic. Yeah, let's look at the raw extrinsic. Okay. Do we have any raw extrinsics to look at? No. Okay, so we have to get a few. I wonder, because it should actually be in an event. I mean, it's also in raw data. Okay, if we are not sure, what we can also always do is visit polkadot.js.org/apps and just look at the source. Look at the true source and find out how we can learn more. So this is chain get block. Yeah, we just look at the latest block. Okay, you find an extrinsic here, and I don't think it is at the raw data within the same extrinsic. Okay, we have signed extrinsics, unsigned extrinsics, so this is not what we're looking for. We're looking for, because it's basically the transactions, autonomous transactions, or transactions executed by the node, but we actually want to look at a extrinsic submitted by a user. This is sealing the block. Okay, maybe nothing happened in that block. Okay, so header, explicit validity votes. This is just empty blocks. Maybe another one. Yeah, basically the biggest part of the block is actually just information from the validators on which parachain blocks to include. So this is usually not super interesting if you read into it. Like most part of the block is just validity votes on parachain blocks. Maybe I'm scrolling to the wrong. Okay, so what do we have here? Here we have, for example, balances, transfer, keep alive. So this is a transfer, and you don't see any information on if it's executed successfully or not. I think this is something that you capture from the events, or do you? Extrinsic. It's a very old extrinsic, and in the earliest days it was a little bit harder to capture all the information. Okay, let's look at the whole block and see what we have here. So we have a balance transfer, but we don't have any associated event that tells us that the extrinsic fails. Yeah, this is bad, because the question now is, how can you find out? So this is one of the things that is actually a real curiosity of Polkadot and Substrate, is that you can look at a block and really wonder where to find the exact piece of information, because Substrate is so powerful and can contain... Hi, Megan. Substrate is so powerful that it has basically, it's a black box. It's a machine that is working internally, and it is always doing the same thing, whatever the runtime is telling it to do, whatever the protocol is. And then from the outside, you can poke it by sending an extrinsic. So extrinsic is basically information coming from the outside. And then the machine reacts to it. But so if you want to understand what the black box is actually doing, the sources of information have is everything that went inside. So this is basically the extrinsic, but the extrinsic is coming from the outside in. So you don't yet know if it's successfully executed or not. And then the machine is giving off events. So this is basically the machine pushing information to the outside. And then the other thing is you can check the chain state for other kinds of information on the machine in this case. But when it, like in the very earliest blocks of the blockchain, it's really hard to tell sometimes why something was successful or failed, or even how, from which state it transitioned into which other state. And so this is where actually the digging comes in, and where you learn the most of the chain. Because sometimes then you start looking at the source code. Sometimes you just dig around. Sometimes you find something, and sometimes you don't find something. Yeah, so in this case, I'm a little bit lost, which is, I mean, if I'm alone, it's easy. I just keep digging. if I'm on a live stream, I'm a little bit more lost. Yeah, that's stupid. How do I see if it was successful or not? Something else that I'm often doing is looking at other people with experience, and so I'm also often looking at the Subscan API, how they are giving away this information. So Subscan is usually like condensing it a little bit better or aggregating the information. And if I remember correctly, they are actually giving this information out with the extrinsic. Extrinsic. So this is a sample extrinsic, yeah, and they are giving you this information if it was successful or not. And I assume they are, I mean, if you look at the Subscan website, it's basically using the Subscan API. So somehow the folks at Subscan were able to figure this out, which you can expect from a block explorer. But how did they arrive at the point of finding out if the extrinsic was successful or not? So balance too low. This indicates that they got a very specific error of the event. You know what I'm going to do? I'm going to check out this specific, I'm taking the hash of the block and I'm asking the RPC to show me what the actual events were at that point in time. This is it an RPC call? I think it's an RPC call. Chain. Is it not chain? Is it events state? Where do I get the events? Get storage. Trace block. Okay. System. No, it's not system. Yeah, so this is really this part where it's you can sometimes find it documented. Sometimes you're digging around in other people's code to find out what's happening, and sometimes you just keep poking at the RPC. So it is chain get block hash. Is it get header? Child state, grandpa, off-chain, payment, RPC, it's not RPC, state, call, get keys, get metadata, interesting. Okay, it's not state, and it's not system. Odd. Okay, then let's look at the chain state instead. But where would I look this up in the chain state? Would it be system event? Events, yes, system events. And then I'm giving it the block hash. And so I can't find the events for that specific block now. And you know, because Subscan is not showing you all the events, they're like filtering out some events that are not super relevant sometimes. I think. Okay, and here we have the extrinsics with deposit balance. This is extrinsic number 1. There, extrinsic failed, and it's not shown in Subscan here, but it is shown here. So we have an event, we have a system event that's being called system extrinsic failed. And it is associated with the extrinsic. So what we do have is that for every extrinsic, there is an event, or for most extrinsic, there is an event that tells us if the extrinsic was successful or if it failed. And we can look at that to build a table of successful and failed extrinsics. And then for every call in that successful or failed extrinsic, we can consider it or we can ignore it. So let's do that actually. Okay, so we're going back to BigQuery and we're going to first look at all the events. we're going to look at all the events that are existing. Let's make a new tab. And we want to find a list of all the failed extrinsics. So select star from alpha chain Polkadot dot events where block number between 10 million and 10 million and okay, so let's get a list of a few events now. Yeah, okay, and we have system as extrinsic success, and let's look for let's just look for successful extrinsics, and section equals system and method equals extrinsic success. Okay, and what we want is we want the block number and we want the extrinsic index. So, and this gives us a list of successful extrinsics. Yes, very good. Okay, so we could make this a view now, but it's a little bit too much effort for now. So let's keep it as a query for now. So this gives us a list of successful extrinsics. Now we can, let me summarize where we are at the moment. We want to look at all the extrinsics that ever transferred value on Polkadot to find out which extrinsics executed successfully. We are building this table here that gives us a list of all the successful extrinsics, and then we're going to join this with the table of all the extrinsics that were ever executed and that were transfers, right? So let me copy this and use it here. Okay, so I'm going to keep this and just going to look at the calls to just see which how the fields are looking. And so okay, so ID, parent ID, block number, extrinsic index. So it's called extrinsic index. This is very good because this means I can just throw the two together. So we have two tables and we basically want to join them. So this means I only want to get a where block number between and block number, no. Yeah, so I want to join this actually. I want to join this with calls, join. I wish I would remember how I do queries. I think this is a subselect, so we're selecting block number and extrinsic index. Just going to see if I received any messages. Okay, so we're going to select the block. Okay, we're doing this as a subselect here. Nope, this is wrong. It's the wrong query. I wanted to have this query here. Okay. This is wrong. There's a copy paste error. Am I not properly copy pasting here? Copy. Paste. Yes. Okay. So I can take this whole query and make it a subselect. Okay, and how do I call this subselect? This is called as successful extrinsics. Not sure. Successful, is this how I write it? Yes, okay. So this is a list of successful extrinsics in a join. Yeah, and this needs an on. So this is called calls. And we're joining this on successful extrinsic dot block number equals calls dot block number and successful extrinsic dot extrinsic index equals calls dot extrinsic index. So okay, now we're getting select calls dot address as sender and calls dot args and calls dot okay, where calls dot block number and calls dot section and calls dot method. So this should now give us only successful transactions. Only successful extrinsics. Okay. And the result is basically a table of all senders and receivers and how much value they transferred. So I'm going to drop my previous table that was called transfers. I don't no longer need it. Delete. And I'm saving this new table on BigQuery table. So this is part of my Polkadot set and it's called transfers. Okay. Okay, so I have a list of all successful transfers. Let's see if I can query them. Okay, this looks much more reasonable now. So this is a list of all the successful transfers I ever had. It's just filtering out. It's basically just everything from block 7 million on, because I don't have all the blocks previously to this. I don't have the events yet indexed. I just started this today. Okay, but this roughly works, and this gives me the biggest transfers that ever happened. And so I see that, for example, a little bit over 200,000 dots were transferred between those two addresses, roughly the same amount, curious, between those two. And then you see a transfer of 100,000 dot, 100,000 dot. Also, this is like awkwardly similar here. Yeah, but you know, it's interesting to find such patterns, because you could start guessing that maybe these were the same entities using different addresses. But now we can look this up. So I'm going to copy this address here and look it up in Subscan and see what we can find. Okay, and yeah, hello to everyone here who is watching this. Feel free to drop me a comment in chat so I know you're here. Okay, you can see very old addresses, but they transferred some value, and it was really a 200,000 dot. I mean, it's not too much today. It's sort of times $6 or so, so it's $1.2 million in value. But you know, this was a year ago. Okay, a year ago we already were in the bear market, but still valuable, right? Okay, so this was the biggest single transfer between an addresses. Actually, we could expect that it's actually higher. Okay, now, so this is let's give this a comment, and now we're looking at, can we find a little bit more interesting stuff? So, but this is biggest pair of sender receiver value transfers. Okay, let's comment this out, and we're now doing something similar, but let's look at the biggest receivers. Who received the most amount of dot in the last 7 million blocks that we observed? So select sender receiver value, and let's remove the sender, and let's just sum up the value, and let's say we want to group by the receiver. So which receiver received the most value? No? Expected end of input. Order by clause. Reference is column value, which is neither grouped nor aggregated as value. Yeah, this works. Good. So we are checking for the biggest receiver. And the biggest receiver of dot all time, only 400,000. I think my data set is somewhat incomplete here. This looks like a too small amount for a single account for me, only having received 400,000 dot. Okay, I will check this. This is some of the things where if something is curious while you're aggregating data, you should always check if maybe some of the underlying data is wrong. Yeah, so this is sort of establishing procedures where you continually improve your procedures, add additional error checking whenever possible. So whenever you discover that you made a mistake, you should think about, can I add additional error checking to my code? Can I add additional procedures that find mistakes? And then when you're digging through data and you have a weird feeling, it always makes sense to check this. So to me, I mean, I could be wrong here. To me, it looks like it's too small of amount to just have 400,000 dots as the biggest receiving account, because I would imagine a centralized exchange account would have much more volume. Maybe I'm wrong and maybe the data is correct, but my spidey senses are tingling here. Okay, so this is the biggest receiver of dots that I have in this data set here. So let's check this account out. Yeah, and this is an active account, and this is this is like active as of 1 minute ago. Is an active account. It's submitting extrinsics, so it is actively sending money, and you see a lot of transfers, right? About double as much transfers as extrinsics. So this looks like a solid centralized exchange account. What's also interesting is it has been voting. With 1 million dots. Okay, and you see here it has 43 million dots. So this is like an obviously shows that some part of my data is incomplete here, and we need to check this. We can check this actually. Maybe this is interesting, but let's think about it for a second. Okay, but yeah, someone was voting with 1 million dots. And then you see also rewards. So this account is also used for staking. This account is also used for staking, and it is receiving 0 dot. Not sure if this is correct. Maybe it's is it maybe staking for 0% commission? I'm not sure how it is in Polkadot. In Kusama you have 10% minimum commission, I think. Not sure how it is in Polkadot. Yep. So, you know, let's zoom out a little bit. What was my original interest? My original interest was to see which are the accounts that have the most value going through. And I would expect these accounts to be centralized exchanges, whales like big investors, and parachains transferring value. I'm a little bit irritated that my data set here seems to be incomplete, because this would now lead me to a journey of actually exploring where my data is wrong. So for example, like maybe let's make a small tangent here. how do I find out how my data is wrong? Where I could get better data? Or how can I find out if my data set is buggy and where it is buggy? And so usually how I approach this is by cutting it into pieces. So by segmenting it in a way that, for example, I could look at how much value was transferred in the range of the blocks 0 to 1 million, 1 million to 2 million, 2 million to 3 million, 3 million to 4 million. And segment it apart in this way, and then see if there is, does it follow some kind of natural curve? Is there like a zero somewhere? Is there like obvious holes? Is it like jittery? Because there could be different reasons for why the data set is incomplete. Maybe the biggest transfers happened many years ago when DOT had a much smaller valuation. So to recap this a little bit, so when we look at Polkadot here, I have all of the blocks, all of the extrinsic, all of the calls, but I'm just started this today. I was a little bit lazy recently. I just started scraping all of these events here. And these events tell me if an extrinsic was successful or not. So as long as I don't know if it was successful or not, I'm now filtering out a lot of useful information. And maybe the biggest value, the biggest transfers in DOT were happening in this area. Or maybe the error is very systematic and it is happening equally among all of my data. This could, for example, be the reason if my ingestion method is not working correctly. This could, for example, be the case the Polkadot runtime is changing the way it operates with every runtime upgrade. And so sometimes the data format changes. Could be that I'm just reading the data wrongly. It could be that the query just showed it in the wrong way. So we can dig down a little bit deeper into the way I'm composing my data and find out where it's wrong. And so one early intuition that I'm having is so this is basically what gives me all of the transfers. One early thing I could do is, wait, did I? Oh, maybe this was a bad idea. Maybe I shouldn't have. Okay, maybe this is the full explanation, is that I just kept some constant values here. So maybe I should check my query before I'm executing it. This would be a good quick win now. Okay, scraping 10 gigabytes. Yeah, let's do this. I think this was the mistake. So let's delete the previous transfers table. This was a wrong one. And while this query here executes over our 10 gigabytes, good. This is what I love about Google BigQuery. It's just super fast. Okay, let's save this table and look again. And maybe we fixed it. This would be awesome because this is a live stream and you don't want to dig around too much in a live stream. You want to have exciting stuff. Hey Megan, thanks for being part of the live stream. Yeah, let's get to the juicy stuff. So let's hope that this fixed my issue. And let's run this query again. Transfer. Oops, transfers. Can I rename it? I cannot rename it. Let's save it again. It's just 10 gigabytes. This is right. Okay. Let's save it again. Polkadot. Transfers. Export. It's not really, I don't think it's really wasting a lot of resources here because basically when a table gets generated, it's static and everything points to the same source of data. So it's not like a dump 10 gigabytes just like this. I just created a new index internally. Okay, so let's run the query again. Okay, please work now. What do we have here? What do we have here? This looks much better. This looks like a way bigger number. If this would be true, the biggest receiver of dot would have received 1 million, 1 billion, 1 trillion, 3 trillion dot. 3 trillion dot. Can it be true? Could be true. Let's check it out. Is the biggest receiver of dot? I mean, this is likely a centralized exchange account, and so this is sort of an indication of volume. Right? If this is a true value, it is an indication of volume because 3 trillion dot don't exist. We have, I think, I don't know, something 100 million dot. I don't know, maybe 140 million dot or whatever in existence. So 3 trillion dot can only be a reference to the volume. Okay. Or just a query that is not working 100% correctly. Please. So how much is this? Is 1 million, 1 billion, 1 trillion. Okay, so this maybe not counting. Let's see if this was a successful transfer of 1 million, billion. What the hell? How can this be successful? Hey, this is not how much dot are in existence. Okay, this is clearly the aggregated value of this transfer that is indicated to have performed successful, but this can't be true, obviously. This is not how much dot is in existence. So maybe Subscan was counting this wrongly, but Subscan is not counting this wrongly. What the hell? Okay, I have to put this on the list of odd things because, you know, sometimes when you dig around the blockchain, you find those weird things like a transfer of 1 million, 1 billion, 1 trillion, 1 quadrillion. What is the next number after a quadrillion? Million, billion, trillion, quadrillion, quintillion. So this is 3 quintillion dot. It cannot be possible. 3 quintillion dot in a successful transfer. I don't think this is true. Okay, this is a fair transfer. That's very odd. Look at this. This is the recipient account. It's the same account that tried this one here. But it doesn't show up in this transfer here. We have to scroll back. Hey. Okay, so it is not showing up in the list of transfers, but we have this account with 1 million, 1 billion, 1 trillion, million, billion, trillion, quadrillion, quintillion, 3 quintillion dot. Okay, you know, so I have to now store this in my list of blockchain oddities that I'm keeping. Give me just a second. I love it when something like this happens. Looking at the block explorer and like, what the fuck am I observing here? Okay, so where's my list? Yeah, oddities. So the 3 quintillion dot transfer, the successful 3 quintillion dot transfer. This is awesome, and I have to create a tweet now on this actually happening. Okay, and then we're going to continue our research. But you know, this is why I love on-chain analytics. Is you just find such weird things. Okay, we just found. Okay, so the 3 quintillion dot transfer. we just found this transfer of this supposedly successful transfer of 3 quintillion dot. How can this be possible? I love this. So, is it successful? Okay, this is very odd. Okay, let's keep digging, but this is very fun. Okay, we have found a 3 quintillion dot transfer that is successful. Let's keep looking what we have. Okay, now we're getting more reasonable numbers here. So this is 1,000,000. This is 1,000,000,000. So this is 50 trillion dot. 50 trillion dot. Yeah, if you want, I can post. I mean, I have just posted it on Twitter here, and if someone wants to take a look at it, I'm going to share it in chat. You should have a chance to take a look at it. Oops. Yeah, posting it in chat right now, so you can take a look on your own. Thanks for being part of this. Okay, so. Let's take a look at this number now, and let's keep counting how much this actually is. So this is like, okay, so this is 1,000,000, 1,000,000,000, 50 trillion. So this is a 50 trillion, much more reasonable number. It's not 3 quintillion, it's just 50 trillion. And I'm beginning to believe, I mean, this could still be like another one of the odd transfers, but you see how sharply the numbers are dropping now. So we will get to the first reasonable number soon, and just keep wondering of what happened here and why did the blockchain think this was successful, and did this ever really happen, or what happened here? Okay, that account, active in several networks, and it is active. It's an active account. Balances transfer might have been closed down. Did an XCM transfer? Okay. My guess is this is an account that was only used a few times. My guess is it did not have a volume of 50 trillion dot. Let's look at the recent transfers. 244, 200 dot. Yep. Yeah, my guess is if you keep digging around the extrinsics, you will find a similar extrinsic of a balanced transfer of. I mean, we can also look at another one. So this is a 50 trillion. A successful 50 trillion dot transfer. Odd. Another one, 50 trillion dot transfer, supposedly successful. Okay. Going to share this on Twitter and putting it down in my Notion, 50 trillion dot. Okay, I'm going to share it with you in chat, and I think if we now continue digging, we will find some real actual stuff in a second. Okay, going back. Yeah, starting to feel that this is also not too real. Even this one here, this is a very round number. You know, I'm going to look at this one And then I'm going to jump a little bit down until we find something that is more reasonable, because I don't want to spend all day with some weird and supposedly... What? Did I not properly copy this address? Or does Subscan now pretend it doesn't know the address? The account was not found. Odd. It's getting weird. This is getting weird. Yeah, similar thing here. I guess it tried to transfer large amounts, and it was even successful transferring large amounts. Okay, I'm going to save this as the table of oddities. The table of odd recipients, I would say. So, the table of odd receivers. And I want to move on now to something that is realistic. Can we please arrive at reality now? Okay, this is the first one that looks realistic to me. This is 346 million dot. So I'm betting on a centralized exchange account here. Yeah, 1 million on the balance. A lot of extrinsic, a lot of transfers. We have found a centralized exchange now. Exactly 1 hour into the live stream. So yeah. So excuse me. So this is now, after 1 hour of creating the blockchain, this is the first time we have found actual usable data. And we have some accounts, and we've found some weird data. So this is the next thing that sometimes happens is when you explore the blockchain, you find stuff that doesn't make sense, but it's also not invalidated by the tools you're using. Obviously, so there can be two explanations. Either in the past, huge amounts of DOT were minted and transferred, or the tools that we're using are not properly interpreting the data. So maybe if you dig down at the raw data, you see that actually the raw data tells you it is wrong, but maybe the runtime was in an exotic state, or maybe no one discovered this oddity because this is like extreme cases. You only find these extreme cases when you're looking at large chunks of data and poking at them in different angles, and then suddenly you find this. But this is one extrinsic of millions, maybe billions. I guess more millions. And it is usually not discovered. So maybe this was a user playing around or so. Another possibility is this was actually happening and then governance intervened and stopped the practice or whatever. I don't think so, because I think in this case, if it would have spread around, it would have made the chain unusable and they might have restarted the experiment. So it's not really clear to me what is happening here. And it's sort of adding noise to the data. The data is now it's not clean data. You have weird instances of big amounts of value transfers. So you either have to manually clean this up, look at unreasonable transfers of money, filter them out, or yeah, maybe you can find a more natural filter, like look at the exact events of this. So for example, let's look at the extrinsic that we originally had that was looking very weird here. Wait. Wrong browser session. Copy. Okay, so this is the free. I guess this is the 3 trillion. Yeah, this is the 3 trillion. Look at this. 28. This is the 3 trillion dot transfer. Maybe it's just wrongly rendered. Look, because it's just. If you look at the raw data, it isn't too big of a number. 1 to 3. This could very well be just a 3 million dot transfer or something like this. Okay, what do the events say? So something goes to the Polkadot, something goes to the treasury, but there wasn't anything real happening here. So this is considered to be a success, but if you look at what was withdrawn and what was deposited, no real value changed hands here. It's just considered to be a success. So this looks like the tools are not showing us the right information. Okay, we can look at the raw data and check it out here in the chain state and just see Polkadot system events at this exact block and just look at what the data was like. Okay, so extrinsic success, deposit, batch completed. Is it a batch? Am I looking at the right data? Oh, no. This was the block with the weird transfer, right? So, okay, it had multiple extrinsics. Was this the odd one? Yes. So we want to look at extrinsic number 2 here. So apply extrinsic number 2. Okay. And let's see, the last extrinsic, the last event for the extrinsic is extrinsic success. So the system was thinking that this was a successful extrinsic, and we see some deposits, withdrawal. But so this is a very strange edge case because no real transfer was actually happening, but for some reason the system was thinking it was a success. I want to take a look at the block here, actually. And so I'm asking the RPC and I'm telling, give me the block. And then I'm looking at the extrinsics and I'm looking for the first signed extrinsic. So I'm actually finding some parachain data here. Skipping ahead. Okay. Para inherit enter. Okay, first signed extrinsics, and this is the signed extrinsic where someone tried to transfer 3 quintillion dot. Got signed, and it was balances transfer. Okay, so somehow the runtime considered thought it is okay to submit the successful extrinsics. Okay, my best guess here is that somehow there was some error checking in the runtime that realized that this is not a valid transfer that could happen. Maybe, yeah, but it is sort of emitted the wrong events. This is my best guess actually. The runtime emitted the wrong event, and maybe it caught the error, it didn't execute the transfer as the user tried it to execute, and then it just showed success. I guess this is my best guess at the moment. Yeah, so you find weird things like this. Yeah, so what do you have to do in such a case? The blockchain will not correct it. It's historical data. So we will have to find a way to correct it. What we, for example, could do is we could look at the events in the same extrinsic and look for the actual balances transfer event. Maybe this would have been the better approach from the get-go. So what you could do is I could either look at the extrinsic and then have a balances transfer, extrinsic. I mean, there's also balances transfer also, you know. This is also the interesting thing. Sometimes there are multiple different extrinsics that intend to do the same thing, and the front end is usually covering for this. So you always have to be very cautious to capture all of them. But the thing is, there can be failed transfers. So what you can also do is sometimes it's easier to look at the events and see if you might find a corresponding event, because maybe, just maybe, sometimes this is the smarter thing to do, because this only happens when there actually was a transfer. Yeah. It just puts the pressure on you to parse the data differently. You know what? I'm thinking if we should end the show on this note here, or if we should keep digging. But you know what? I'm going to take a 2-minute break here from the stream, bio break, and then we're going to continue this. So see you in 2 minutes. Okay, so you know what? Let's actually do this. Let's look at the blockchain, and let's not look at the extrinsic, but let's look at the successful balances transfer events. And look at them. So I'm going to. So this is successful. Okay. So what I'm going to do is I'm going to comment this. This is the extrinsic approach. Can yield weird results if the chain responds extrinsic success, but it cannot reasonably be that way. And I'm going to comment all of this out. But you know, this is sometimes those failures teach you a lot about how the blockchain is working. For example, that it can end up in such a weird state. And we are starting anew. So I'm going to keep this. I'm going to close this. We don't need this anymore. And we keep this. And ask about the events, and maybe just see if the query executes like this. No. So it is maybe a verb. Balances transfer. Maybe it is a big T when we're dealing with events. Yes, for some reason it's a big capitalized method name. Okay. So, and we have, okay, we are starting again from the beginning, but we learned so much that we will be quicker now. So this is a list of all the balances transfer events. And what we see here is we have the amount, we have a from, and we have a to. Everything we need neatly lined up. So what we're going to do is I'm going to copy this, and we don't need this tab anymore. Close. And I'm going to add this here. And so what we want, I should have kept it one more second. So what we want is so this is data from is the sender, data 2 is the receiver, and data amount is the value. And then we're going to parse this as a string, and then we're casting it to a big decimal. Cast as big decimal, right? And this is a string, and this is a string, and I think this might be the much slicker query actually to give us some insight into what is happening. Executes quickly. Okay, Genge Kusama is writing, it's not positive as events that are less striking will be difficult to point out. I'm sorry, I don't really know what you mean by that. Maybe you can add a little bit more detail so I can get what you mean. Okay, so yep, we basically get the same data set as previously. So let me apply this to min block max block. It could just be that the events table is much bigger, that the query now consumes much more data. This is why I usually prefer to go over call data. Oh, still just 10 gigabytes. This is good. It's very good. Good. So I'm querying events. Good. Let's run it. No. Did I aggregate it previously? Yes, I grouped it. So group by sender and receiver. And this means I want to have the sum of all the value here. Okay, let's run it. And this will be our new base table, and it will be much more precise than the previous one, so I can delete the old one. And we should not find the same odd stuff that we found previously. So sometimes having the best precision prevents you from finding the odd stuff. Okay, this is our new table, and we will save it. BigQuery, and this is our Polkadot transfers table, right? Yeah, this is basically what every block explorer gives you when they give you insight into all the transfers. This is very close to what they're actually doing. So we got this, and now we can execute our previously executed thing again, and see who is the biggest receiver of real dot without the weird fake events that we got previously. Okay, and we have some results here. Okay, so this is looking much more real. So 1,000 and a million. So this could be an account that had a volume. So maybe incoming dot over its lifetime of almost 400 million. Let's see. Let's compare and see what this account is. Okay, I think this is this is the centralized exchange account that we previously saw. So we could actually now start keeping a list of interesting accounts. So this is the biggest receiver of DOT, and we can now go through them, and maybe let's do this in a quick succession just to check out a few accounts and get a little bit of a feeling of what we're dealing with. So I guess this is another centralized exchange, yes, with 277 in sort of, let's say, let's call it volume. It's not exactly volume, but it's sort of close enough. This side is not responsive. Okay, yeah, has 43 million DOT on its balance at the moment. Okay, going to the next one, 64 million DOT, and it has income. It has basically incoming transfers of 111 million DOT. Yeah, and so it goes down now, but this is sort of interesting because, oh no, this is not a centralized exchange. Look at this. This is someone who's staking. So this looks more like a whale account, right? Only a few extrinsics, few transfers, is also voting. So someone who is engaged in the ecosystem. Oh, and what do we see here? Voting. What is this voting? So this seems to be Binance. This seems to be a cold wallet of Binance, maybe with 64 million dot. Yeah, so this is actually where we can now start mapping out the ecosystem, and this is what I actually wanted to arrive at. Okay, this is another centralized exchange that has 0 dot right now, and it seems like it stopped operations 119 days ago. What you can often see is that the last transfer out is moving into another wallet. So this is where you can then start crawling around blockchain and look at stuff. Okay, seems like a holding account, like a cold wallet for something that looked, yeah, that very strongly looks like it worked as a centralized exchange account and is now working as a cold wallet. Yeah, so originally you see they funded the same account. They funded the account with 1 dot, checked that everything is fine, and then transferred all the dot. You can imagine how exciting it must be to transfer 283,000 dot. Okay, I would say we go through the top 10, look at the top 10 here, and then we maybe we can also look at the biggest senders. But this is sort of actually the point that I wanted to get to today, is map out the biggest volume accounts in the ecosystem. And you can imagine that the senders are very similar to the receivers. Okay, one account holding 10 million dot, also centralized exchange account, 68 million dot in volume. Yeah, it's actually interesting to see the volume of such big accounts. Another exchange, much lower amount in comparison, low holdings, also staking, and has been voting at some point. Yep, so this is also when you map it out, you can find related collators and basically also find relationships between collators, centralized exchange accounts. Okay, another centralized exchange. So basically, if you sort by biggest volume, you naturally find centralized exchanges because they're generating the most volume. Okay, and we found a whale, and it seemed like the whale closed down their account. 500,000 dot going out in the last moment. Oh, no, yeah, moved it to a centralized exchange, maybe. So looks like a... Oh, excellent question, Megan. Excellent question, Megan. We're going to take a detour now on your comment. So let's say we're done with this. I mean, we could go through this list now, and what we would find is centralized exchanges, and then all kinds of whales, or maybe at some point you reach nomination pools for validators or validation pools or something like this. Okay, but your comment now, Megan, is something where I can chime in. And so, Megan, you're saying, I wonder how soon we'll be able to train AI to parse through blockchain data. And this is actually something that I want to go to with Polkalytics. And this is something that I only realized after starting out with Google BigQuery, because, so this is part of the Google Cloud. This is Google BigQuery, and Google is naturally drawn to AI, and so they actually have tools. I have the tools available. I could start looking into this. It's just it would keep me busy with the stuff that is not my focus right now. But so Google Cloud AI, there are actually tools that you could use and let them run against the data set. Let's take a look at what they have to offer here. So, okay, machine learning. Yeah, so this is something interesting, AutoML. And AutoML is basically for people that don't know a lot about machine learning and AI. And here the idea is that it is a set of proven machine learning tools and methods, and you have a data set. And so basically what they do is they tell users of, you have inputs, you have outputs, you want to predict outputs. Give us a table to learn from with the predicted outputs, and then we will try to find the best machine learning model for you that fits that data set. And so AutoML will then run through different kinds of machine learning techniques, all apply them to the same data set, and then see which one fits best. Parameterize it for you, basically find the best parameters. And then you have a model. And then you can apply that model to other things. So this is a product designed for people that sort of can work with AI if you train them properly, but they don't need to know everything, or like you can have a very rough understanding of how machine learning works and it might be a thing for you, right? So this is AutoML, and this is something I want to look into because I've been always looking into AI research and machine learning, but yeah, I guess you have to dedicate your life to it to become sort of proficient with it. And if you have the tools at your fingertips, why? It's like would be a great start. Okay, and then there are some things that are more specific to big data, if I remember correctly. Yeah, we could. I mean, let's open the tab of AutoML and. Not sure if Vertex AI is for me. Whoops, but let's open it in a tab. Now we're going to look at it. But let me scroll down a little bit. No, maybe this was already the offering. Okay, what is Vertex AI? Blah blah blah. AutoML. BigQuery ML, yeah, BigQuery ML is what I've been looking for because I have BigQuery. Okay, so BigQuery machine learning, right? So I have BigQuery, and you basically what you need to do is you have a data set, and then you need to label the data. The actual job is to predict. The actual job is to know what you actually want to predict, right? What do we want to predict actually? This is where you actually have to spend your time thinking. And then, because first you have to formulate the outcome that you want to produce. And what you always want to predict is you have a lot of input variables and usually one output variable, or usually you can condense it down to a single output variable. Of course, it's possible that you want to have multiple output variables that you want to predict, but it helps to consider in a way of, do I really need multiple outputs, or is it maybe still a single output that I need and then I can do more later. So in the context of blockchain, what could be interesting to predict is, for example, let's look at Polkadot, and you have multiple parachains. And so you can map out all the parachain accounts, the sovereign accounts of each parachain living on Polkadot or Kusama. And so you have a list of 30, 40, maybe 50 accounts. So 50, let's say you have 50 parachains live. And then you feed it historical data of when did money flow in, when did money flow out. And maybe you can build a model that predicts momentum. So if you see a certain uptick in volume, can you predict the amount of volume that it will reach, or how much, if there's a sudden uptick in value, can you predict the price change, for example? For example, let's say you correlate net flows of DOT or KSM that is flowing in and out of parachains and compare it with future price. that would be an excellent thing to predict to trade, or basically not front run the market, but get a very early indication of where the journey is going. This could actually be interesting, you know, because having on-chain data available to you would be a very interesting thing. Maybe this is something we should actually look into. It sounds like it could provide some riches for us. It's nice to have a few people here on the stream. You can let me know what you think about this. Okay, let's think this example through. How would we do that? So you need, basically the output you want to have is a predicted value of DOT in 24 hours, in 1 hour, or in a week. It depends on the time frame. Or maybe the machine learning model can do that for you even. But let's go a little bit traditional about it. Let's say you want to predict the price of DOT in 24 hours into the future. And what you can give it is your whole data set. So you would have to have maybe current price also as an input, maybe as the biggest predictor of the future price as the current price, and then all the other inputs. So we would need the current price. We would need the current price, and merge that into the data set, and then look a little bit into how the machine learning model works. How do you want to construct the inputs? How do you want to, what do you feed as the actual input into the machine learning? And getting historical data is not too hard. For example, where it is available for historical data is Kraken. Kraken has a website where they have historical price data. This is where I usually retrieve it from. I'm sure there are a few sources. More interesting thing is to get current data on a predictable rate. So I guess there are still a few sources, but this is something that I haven't really looked up. But this is actually something that we could look into in the next month or so. Maybe we should do that. Maybe we should do that. Okay, I have maybe half an hour more where we could do some research into predicting prices. Oh, let's start with something simple. So we want to identify. Maybe we don't need to. So one thing that is interesting for me is what are the biggest accounts of the ecosystem? What are centralized exchange accounts? What are parachain accounts? And this is something that I actually would like to map out. So maybe let's start with, to have something to close down the session today. Just let's take a look at the data that we have and write it down and make it somewhat human readable. Make it understandable for humans what we actually got today, so that we have something to present to the community. Okay, so let's do that for maybe 20-30 minutes, and then we close down the session. So this is where it gets very tangible now. This is where I take the list of all the transfers that we got, so all the accounts and how much DOT they received. And we're going to give the thing a name, basically create a real table of real data. So I'm going to create a spreadsheet, and so net flows. I'm going to create a folder here, and we're going to create the spreadsheet. So and address. Yeah, let's not make it too complex. We're just going to take this list here. This is the list of the biggest receivers. Yeah, I think that's sufficient for now. And we just store this into a Google Sheet, right? right? I mean, this is 1,000,000 rows. This would already make some nice statistics. I'm not sure if this actually stores into. I'm not getting any feedback. Okay. So 100,000 of the 1,000,000 addresses got stored. Yeah. But you know, this already actually gives us an indication of how many addresses have ever been created, because we have the actual number here. Oh, no, not how many addresses, but basically in the last 7 million blocks, because we didn't scrape all of the blocks, but in the last 7 million blocks, we had a little bit over 1,000,000 receiving accounts on Polkadot. Okay, Megan, you're saying this is easy stuff, what I'm theorizing, but actually, what I'm theorizing is it's easy in practice. It just requires work. It's like more manual work, I think, than real hard science, because I mean there is some sophistication to it, but I'm betting with you, because Google was very serious about this. I'm betting with you I could spend, let's say, 4 hours, maybe 8 hours, maybe 12 hours with AutoML or BigQueryML, or like, I don't know, maybe 2 hours of reading, then you start your first experiment. And then after some experimentation, you get an actual idea of where you want to go. So I think within 8 or 12 hours, you have a rough idea of how the structure would look like that you have to build. Because you just have to provide the right input data set and get the right output data. And then it's sort of manual labor of getting the data and writing a little bit of code that transforms it. Of course, experience helps, but in a way, it is more manual labor and just putting the data together and figuring out the quickest way to put the data together. And it's on this level, it might not even require too deep of an understanding. Okay, but let's get to work and not talk too much here. Okay, so we have a table of the biggest recipients of DOT. And can you format this because it looks ugly? Google has a new design here. It's irritating. Format number. Okay, much better. Okay, and we say this is the biggest receivers. Okay, and now we want to create subscan links so that we can easily, quickly look at this stuff here. And so a subscan link is composed of this and then the address. So, so we have a hyperlink, and the URL is this string and this field, and then we want to have a label into this link. And so we have a single link to this. Let's check if it works. It works, and so we can apply this to all the rows. If my pen would be doing what I wanted to do. Okay, let's do this with the mouse. Yes. Okay. So this is a list of links, and now we give it a label. And I think I'm going to close this, close this. And we close all of those tabs. We'll look at this later. Okay, and now begins the boring work of looking at stuff. Okay, no, let's just begin with the first one, and we're now mapping out the ecosystem. So I would do this, maybe not all on stream, but my work is now to map out the biggest 50 or 100 accounts and look at what they are actually doing. So maybe we give it a label, and we also give it a category, and this looks like a centralized exchange accounts. And then we have a label, and maybe we have also a few notes. Okay, so this is a centralized exchange account, and it's big. So if it's big, it's likely Binance or Kraken or Coinbase. And we don't have any indication here. So what would, for example, help is if we could find related accounts. So we could look at who are the biggest givers and receivers for that account actually. Maybe, okay. You know what we can do? We just put the address into Google and see if this address is a well-known address somehow. For example, .scanner. What is .scanner? Can it give us any information? No. Maybe someone has ever annotated this. Maybe it's annotated in Subscan itself. Is there comments? No. Oh, someone tweeted about it. Polkaholic engine. And then someone was parsing balance transfer data, so you see we're not the only ones. Multi-chain airdrop. Okay, this doesn't tell us anything. I think there is no public repository so far about what those mean. Maybe we should actually make this a public project to annotate this, because I'm sure someone has been dealing with that address and knows what's happening here. It's weird that you don't get any identification of big wallets like this. Binance seems like, you say? Yeah, it's hard to tell. I mean, we saw one Binance wallet before. Yeah, this is a really tough one. How can you figure this out? Oh, it was written Binance in one of the links you closed. Oh, okay. Okay, I'm going to open the links again, and maybe you can, I'm going to say it because we're not communicating in real time here, but okay. I don't see anything that says Binance here. I don't see anything that says Binance here. Okay, wrong link. Yeah, not sure. I don't. Okay. If you see where it says Binance, tell me please. Okay. I don't see anything that says Binance here. So this is Affinity. Huh? Binance. Oh, okay. Yep. Good catch. Thank you. Good catch. Thank you. Okay. So, source Binance. Okay, and we also see some other something other here, and that is here, this 12xt. So let's find this one. Oh, it's the next one. So centralized exchange, good. Kraken, source. Yes. Okay, good teamwork. Good teamwork. We got this. Very good. So it means, okay, Binance is just, transferring stuff. And later on we can look a little bit into the details of, how is this? Can we label stuff here? No. Okay. Is this not a Kraken wallet? Yes, this is the Kraken. But this is odd, because did I just open? No. Oh, okay. The second link. Okay. Yeah, so the second link, we assume this is Kraken shell. Look, interesting. It has accounts on 9 other networks. So it seems to operate with the same keys, which actually represents an operational risk, if you ask me. But yeah, hard to say. I guess maybe it's a multi-sig. Okay. Okay, what do they keep here? 5 million of A-star, 4 million of centrifuge. Yeah, okay. This is hot. 40. 1 KSI. Okay. Yeah, interesting. Okay, so we got this and maybe we have sources here and on multiple networks. We keep some notes here. Okay, so if I remember correctly, we just saw that this one here belongs to Binance, right? Because here wrote, so this also has to do with Binance. So this is a second Binance wallet. Binance voting. So this seems like the hot wallet, and maybe it's the cold wallet. No, this is the exchange wallet, and maybe this is used for different purposes because it was voting and it was getting staking rewards. So this is possibly, yeah, this looks like it is the staking account of Binance. This is my guess. So this is a staking account of Binance, right? Okay, next one. Has been active is closed, closed down account. But before that, it was very active. Let's put it to the Google test. Yeah, okay, not a lot of mentions here. Dot scanner, oops, no, there was something. Not too much here. Not too much here. This is a really not yet worked on mapping out the ecosystem. Okay, so this is a closed down account, so we also need a status. Status. And this is active, this is active, this is active, this is closed. And it looks like a centralized exchange account because it had activity going on until 4 or 5 months ago. Yeah. Okay, and we see a last outgoing transfer, so maybe this helps us identify something, but not really. Okay, we would have to look deeper into this, but maybe other people can share some information here. Let's go to the next account. This is also centralized exchange. Let's see what Google tells us. Okay, few results. Okay, there was a whale alert. Okay. Yeah, okay, so someone was experimenting and looking at this account, so maybe at some time, some point in time it was the biggest account. But it is a centralized exchange account, and it is active, is it? Hi, Ayuna Nick. What are we doing? Okay, let me give a quick summary of what happened so far. We looked at all the transfers that ever happened, learned a little bit, found a funny transfer of 3 quintillion dot and 50 trillion dot single transfers that are flagged as successful by the Polkadot chain. But you know, my theory is it's sort of Polkadot emitted the wrong event and it actually failed. Then we changed our approach, and now we're looking at the biggest receivers of thought of all time. And the biggest receivers of thought of all time are likely going to be centralized exchanges, because they basically have a lot incoming, outgoing. So the hot wallets of centralized exchanges are the biggest volume accounts. And now we decided to just map it out and see what is there in the ecosystem. So we have found a Binance hot wallet, a Kraken hot wallet, and a Binance staking wallet. And we're basically closing down the session. So this is the last 10 minutes of this session, and just looking at a few accounts and see what we can learn about the ecosystem. So this, for example, seems to be Block Daemon. So this seems to be a wallet. Might be a centralized exchange, but there's not too much volume going on here. Maybe it's a little bit of a small exchange. Yeah, it's thanks, Nick. This is we we theorized a little bit about what we could do. So this might be. Don't want to promise anything, but this might be evolving into a longer-term project where we are trying to provide the data set for machine learning to maybe feed a machine learning model that might be able to predict the price based on momentum. But just a theory. Okay, so this account, we could look up what Block Daemon is, because at some point, what is vote? Block Daemon. Institutional grade blockchain infrastructure. So someone, I don't know what a vote means here on Subscan, but it seems, is this governance voting? I don't really know what this is. Or is this like bonding? Maybe this is a bonding of, I don't know. I don't really know what this means. But this is a staking account actually. This looks much more like a staking account than a centralized exchange account, and maybe it's associated with Block Daemon. So staking and Block Daemon, maybe? Yeah, so it's the last 10 minutes. It was actually a very interesting session for me, and I would like to also map out parachain accounts. Maybe this is something I will show you, because now going through this is not the most interesting stuff of the world, even though we might discuss something. Let's do number 9 and 10, and then as a last thing for today, I will show you how you can find parachain accounts on Polkadot and Kusama, because this is also something interesting to look at. Another interesting thing to look at is treasury accounts, because there is a very funny thing in Subscan that all treasury accounts are basically connected because they share the same address, which is a little bit odd, but it seems to be true. Okay, so this looks like a whale account. Wow. So this is a whale. Okay, it wasn't staking, it's just whaling, and it's closed down. So this is a closed account, and this was a whale account. Wow. Okay, so this seems to be the biggest volume whale that we found. Let's just see if we can find any annotation for this on Google. Not really. .scanner is having good SEO. Okay, this is the last one, and then I show you my trick. Okay, another high volume whale, and this was a staking account, but non-identified. Okay, so this is the top 10, and this is a staking account. Okay, so two last things for today. How can I find the parachain sovereign accounts, and how can I find the treasury accounts? So we're going to look at Subscan, and we can make this a little bit bigger. Okay, we're looking at, so in Subscan, how can you find the sovereign accounts? And this is basically, this is sort of, I mean, it's open, it's not a secret, but it's still alpha, because I think Not many people really notice or care about this. Okay, so, and it's fairly easy to find. So you go to subscan and you go to Polkadot and Kusama. So you go to the relay chain subscan. And then in the parachain menu, you go to parachain, I think. And now you see all of those parachains. And let's take my good friends, Mangata Finance, where I'm the growth lead. And let's find it. So it's should be 2110. Did I pass it? 2110. Do I have it in the wrong memory? Oh, this is Polkadot. I'm looking at Polkadot. We're not even Polkadot, we're in Kusama. Okay, Mangata is not yet on Polkadot, so let's look at our friends. Who is holding DOT? Let's look at an exchange. You know what? I'm actually interested in Hydra today. So let's look at Hydra. Okay, so you have Parachain 2033. Okay, and now on this screen you see several associated accounts. So the owner is the owner of the Para ID. So this is basically the account that originally registered the Para ID. It is an owner. And I'm not even sure if you can change this. So this might be eventually the last centralized thing that will be on Polkadot is the owner. But maybe you can even transfer ownership, because I think actually if you have a really truly decentralized parachain, it would be self-owned. But you know, you have to have an account that originally creates the Para ID, and the parachain is not strictly bound to the Para ID, but everything that has to do with XCM, when you register, when you open up a channel, is always bound to the Para ID. And if you have a multi-location, so the thing in XCM that identifies the address of a token, the original address of a token, it always has to do with the Para ID. So the owner is an interesting thing. I think at some point it will become maybe a technical question result. Okay, fund account, this is the crowd loan. If you had a crowd loan, this is the fund account. And then sovereign account. So sovereign account is a special account. And this is basically the account of the parachain. So the parachain itself can interact on Polkadot, for example. And this is the account where if you as a user do an XCM transfer, a cross-chain transfer of tokens to a parachain, this doesn't really happen. What really happens is you are transferring your DOT to the sovereign account of the parachain, and then the parachain says, I received DOT, and the only thing that dictates, basically you're giving this DOT to the parachain, and the only thing that dictates what is going to happen with the DOT is the runtime logic of the parachain. So if you have a malicious runtime logic, it would just take your DOT and it's gone forever, like bad luck for you. So you cannot trust any parachain. You would actually have to verify the code for each parachain, which is not too much happening in practice. And at some point in the future, we will see something bad happen because of this, or governance incidents happen because of this. Yeah. But so this is what actually happens. So the sovereign accounts is the accounts that are keeping the value, and this is sort of a related concept to total value locked. So we're looking at Hydra now, and so you can see how much DOT is actually in Hydra. This is the value of DOT actually in Hydra. So you can go through this list of parachains here, and then go into each parachain. You find the sovereign account. You go into the sovereign account and you note down how much DOT is there. So if, for example, there is 100,000 DOT in Hydra DX right now. And then you can see how much is going in, how much is coming out. So a lot of people are sending DOT to Hydra DX. And this sort of relates also to the XCM transfers menu. So basically this is a representation, or is another way to express an XCM transfer, right? Okay, so this is how you can find sovereign accounts, and if you want due diligence a little bit of how much money is going in and out of a parachain account, this is what you can do. So this is number one. And the last thing I'm going to show you for today is how you can find parachain treasury accounts. So I think it's not strictly given that every parachain conforms to this standard, but I found this by accident recently, that it seems that many parachains are having the same treasury account. So where can I find the treasury governance? Treasury too? Can I find the treasury? You know what? We're going to Polkadot.js and look up how much money there is in the treasury. This is maybe not the smartest approach, but it is sort of workable. Look at how much is in treasury. 44 million dot, and then I'm going to look at all the accounts and just look for the account that has 44 million dot. And it is there. Yep, so this is how you find the treasury. Okay, and so this is the funny thing now. This must be fairly new. So I was looking at this, and then you see this account has asset or on-chain data on 29 networks, which of course the Polkadot treasury does not keep 29 accounts on 29 different networks. So you go to the screen, and what you actually discover is that you here can observe all the individual treasuries being aggregated together into a single screen. So this is only their own tokens. If you have diversified treasuries, you won't see this here, I think. But for anything that has a value, you basically can see on a single screen how much individual treasuries are holding. So, wow. I mean, there is always the question of exit liquidity. So just because you see a value here doesn't mean that this can be realized, because basically this is highly dependent on how much liquidity there is. And if there is a heavily manipulated pool with very little liquidity, this value wouldn't have any meaning at all. But you have to look at it on an individual basis. But basically, so what we're seeing here is now how much are the treasuries holding. This is very obscure. Biggest guess is when you have a protocol where you would, so maybe I'm not doing them the right honor here, but my guess here is that this treasury isn't really holding 112 million in value. And so what could possibly be is that the treasury has a lot of tokens and only a few tokens are in circulation and only a few tokens are being used in liquidity to determine the value. And this is usually gives a lot of imprecision to the price discovery. So if there is very little liquidity or very little tokens in circulation, circulating supply, and a lot of tokens being held, for example, by a treasury or company account or whatever, it gives the market a very hard time to come to a price discovery. So whenever you see a token, I think one of the biggest questions, if you want to come to the true valuation, so to say, I wouldn't even say market cap, because market cap can also be very misleading. Any metric can be misleading. It's really hard. Market cap is, in my opinion, I've been thinking about it a long time. Market cap, not fully diluted value, but market cap is some of the most true values you can find. And you should always compare it with liquidity. Total value locked in liquidity against the token, because the liquidity sort of tells you, the bigger the liquidity, the more true this value is, because the bigger the chance for the market is to express itself in a true value. Okay, rambling a lot. Polkadots, this looks sort of true. I mean, I don't know what the liquidity of Polkadots is. Calamari, I'm not sure how much it is traded yet. A-star, yeah. So this is all starting to look reasonable, right? So this is where you see how much the treasury is holding. So this is a very super neat shortcut to find such things. What is deep brain chain? And I think on that note we're closing it for today. So what we did is we discovered a free quintillion transfer that Polkadot claimed is a valid transfer. the tokens were never transferred, but Polkadot still believed it was true. And yeah, we started beginning a list of the biggest volume accounts, and maybe this is where I will continue the journey. And I will also start noting down all the sovereign accounts because I would like to start measuring net flows between parachains, actually. Yeah. Okay. Yeah, so I'm closing down the session on this note. It was very nice to have you today. Megan, Genge Kusama, and Ayuna Nick. It was very nice having the conversation with you. If you like it, you can click subscribe on YouTube. Click the upvote because then you will see YouTube pushing this to you. And it's very nice to actually have people in a conversation with this. And yeah, maybe I think we will do more. I just don't always have the time to do things like this, but yeah, from time to time we can do it. So have a good morning, evening, noon, midnight, and all the best to you. Goodbye.